The PosiTest Air Leak Detector is used to find air and water leaks in air barriers, roofing membranes, and waterproofing materials. It's an upgrade of the old Retrospecs AirSure leak detector that was introduced to the industry in the mid-1990s. As a point of background, the ANSI/ASHRAE IES Energy Standard 90.1 2010 and the International Energy Conservation Code 2012 require that building envelopes be designed to control air leakage. The IECC also designates paints on concrete block as an air barrier. In order to comply with the mandate to restrict air leakage, a variety of materials are used during construction. Testing is also performed to confirm that leakage doesn't occur. The bubbles here show a leak. In order to use the detector, a surfactant is first applied to the area being tested. A dome is placed over it and a pressure differential is created, drawing air through the leak or deficiency to show the bubbles form as you see here. The primary areas of concern for air leakage are joints between the materials, penetrations through the materials, like fasteners or masonry ties, and junctions with other assemblies. In the case of paint, the paint film itself should also be tested. ASTM E1186 is the industry standard for air testing. 5 methods are performed upon completion of the construction. 2 other methods are for localized testing of ties, for example. Again, the chamber is being placed over the tie, a pressure differential is created, and the leak is shown by virtue of the bubbling. The PosiTest is described in 4.2.7 of the standard, and it can also be used for forensics work, for example, on this roof after the fact, looking for leaks. I want to show you the components of the PosiTest Air Leak Tester. We are going to use it in the field, but before we go there, I want to show you how it is assembled and basically some of the operating buttons. The unit consists of an 18-inch diameter polycarbonate test chamber. The testing unit itself that creates an air pressure differential using a fan, and you set different values in it. I'll show you in a second. You apply a test solution to the surface that will create bubbles once the dome's put on and you draw the air through it. And there's a 5-foot diameter hose that connects the test chamber to the test unit. To power the unit up, you press the green button. Next thing you must decide is whether you're going to operate in the automatic or manual mode. That's by pushing this top button. Push it once for automatic. Push it again if I want to go to the manual mode. I'm going to go back to automatic, which is recommended for the unit. The next thing the user must do is set the pressure differential limit. That's done by pressing this button, which changes the pressure in increments of 100 pascals. It goes up to 900. I'm going to cycle back now to 500. 500 pascals is equivalent to about 10 pounds per square foot. The pressure differential is created by really adjusting the fan speed. That's what pushing that button does. The rate of depressurization is adjusted by pushing this button. It changes the rate in increments of 5 pascals per second, and the common setting here is 25. We recommend the use of the auto mode, particularly when starting up. If you don't use auto, then you have to adjust the pressure differential manually and the rate of depressurization manually as the test is being accomplished. Now to start the test, I push the green button once, press it again. The dome is in place and it's going to cycle up through to 500, which is what we had preset the value as. This shows you that the pressure was 500 pascals and the total test took 22 seconds. Now we can store these values. We can store them by pushing this icon. Push it for a passing test. Or if it's a failing test, I push this button. It'll store either pass or fail. You can also download these to the computer. To run the test, First, clean the test area of dirt, dust, and debris. You should also not be too hot from torching or frosted or extremely wet when you run the test. Apply a thin film of the solution over the test area, but don't apply it too heavily, otherwise the solution could froth and foam. Once the solution's in place, hold the dome firmly to the surface. You don't have to push too tight to create a perfect seal because the fan will make up for the difference. But then push the green button once to activate the unit and a second time to start the fan. If you look through the dome, you will see in the middle of the dome the formation of a bubble, indicating that an air leak has occurred. The surfactant in this case is bubbling up by virtue of the air being drawn through the block into the test chamber. As you have seen, the PosiTest Air Leak Detector is an excellent instrument for finding the presence of leaks in joints, seams, materials, including paint during construction, so that repairs can be made. For more information on KTA learning videos, log on to ktauniversity.com.